back. I've got an unusual bit of physics to show you today, and I'm going to set you a little puzzle to see if you can solve. And it's about something odd about the glasses that people wear if they're short-sighted. So, I'm wearing the kind of glasses people wear if they're short-sighted. Remember the hints in the name, short sight. You can see things short up. But things that are far away and distant, like looking at distant mountains or even sitting in the back of the class and looking at the blackboard, is something that people who are short-sighted struggle with. So they wear glasses to help them overcome being short-sighted. You'll notice that the light goes straight through these glasses and out the other side, and it goes both ways, which is why you can see my eyes. But the puzzle I'm going to set you is rather unusual. What happens if I put these glasses in front of a bright light and look at the light that comes through them? And I think you'll be quite surprised. So I've got a very bright light source here. It's an old-fashioned overhead projector. And what I'm going to do is I'm going to take these glasses for short-sighted people and hold them up in front of the bright light and against the screen. And I'll show you a bit closer what happens, but it should surprise you. So here goes. Let's take the glasses and hold them up in front of the bright light and have a look at what you see on the screen. And it's quite surprising. You see what appears to be a shadow. And it's not because the glasses are one way round. If I turn them the other way round, they still produce a shadow on the screen. But that's odd, because doesn't light go through totally clear glass? It certainly went through so you could see my eyes when I wore them. But when I do this, I just seem to get a black mark on the screen. So what do you think's going on here? So, if you look a bit more closely, you might notice that behind the lenses it does look a bit dark, but it's not in complete shadow. But interestingly, around the outside of the lens, you'll see a halo of light outside of the frame. And this is key to explaining what's going on here. So, before we go for a full explanation, one of the things you need to notice about lenses that are used for people who are short-sighted is that they look dished inwards. In other words, they're concave lenses. So let's have a closer look at what concave lenses do. So I've got my little laser ray set up here, and I've also got a concave lens. This is a biconcave lens. In other words, it's dished inwards on both sides. And if I put it in front of the light beam, it's much as expected. The light goes through. But what happens if we switch on 3 rays and put the concave lens in the way? This is the same lens that was in short-sighted glasses. And what you'll notice is that the rays bend outwards, that they diverge, they spread apart. And it's this that will explain what we saw on the screen. So the problem with people who are short-sighted is their eye is too strong. When the rays come into their eyeball, the rays bend together too much and cross over before the retina. So what you need to do is to take the light that goes into the eye and bend it out a bit further than it was when it was coming in. And then the eye brings these together and has to bring them together a little bit further. So people who are short-sighted have to wear concave lenses in their glasses. And we'll use this to explain why we saw what we did on the screen earlier on. So, here's the concave lens in front of my screen, and you can see that the light going through the lens produces not a shadow but a sort of grey spot, and to the left and right of it are bright patches. And now you know why we got that effect with the glasses, because what's happening is the light is coming through the lens and it's bending outwards. So directly behind the lens, you don't get quite as much light on the screen as you thought you would. The light is actually, in this case, bent out to the left and out to the right and made it brighter to either side. In other words, the intensity straight through is not as bright. The light has spread out over a much bigger area. And those two light patches you can see on the left and the right are the light that would have gone straight through and made it light on the screen if it was a flat piece of glass, but because it's concave, that light has been diverged or bent outwards. So there's your explanation for this rather odd effect, that if we put a piece of transparent glass in front of a screen, it actually looks as if it's blocking the light. So now we know that people who are short-sighted wear glasses to actually bend the light outwards, diverge it before it comes into their eyes, because in general their eyes are too strong. They refract or bend light in too much, so they need a lens to bend it out first before it enters the eye. So, hope you enjoyed that video, and I look forward to seeing you again next time.